whoever are not able to join, okay, ask them to wait for 2 minutes. I'm sharing the YouTube link. Just give me 2 minutes. Yeah. Uh, yes, guys. Yesterday, what did we discuss? Yesterday, we discussed single circular linked list and double circular linked list, and then stack. Okay. And coming to the stack, stack can be implemented either by using linked list or by using a normal list. Okay. So actually, you should have a clarity because there are so many operations on stacks and queues, mainly stack. Okay. So that's why you should have a clear idea of stack. Okay. So we can implement stack either by using a single linked list or double linked list. Yes. Okay. So if it is a single linked list, okay. So 1 minute, I'm just opening some text document so that I can write. Okay. So give me 1 minute, guys. So let me share the screen. I hope you can see the screen now. Yes. If you cannot see the screen, please send me a message in the chat box. Okay. So coming to stack. Okay. So first thing you need to know about stack is nothing but last in, first out. Yes. So normally, so whenever you come across stack, okay. So you will come across these things, which is nothing but generally will implement stack by using last in, first out. Or can I also write first in, last out? Generally will not do it. Okay. So either last in, first out, or first in, last out, both the same only. Yes. Either even if you implement leaf or below, both the same. Okay. So and yeah. Coming to stack operation, so what are the notations you need to know? So whenever you're implementing stack, okay. So we have seen yesterday, but I just want you to revise because stack is kind of an important thing. Okay. So stack operations. Okay. So what are the stack operations? Stack operations is nothing but push, pop. Okay. So we have seen yesterday peak. Yes. Okay. So and then if you want to find stack length, so I'm also writing length. Yes, so generally these are the things you'll be using mostly. Okay, displaying the stack. Displaying the stack. Yes, okay. So and coming to this thing, stack can be implemented in number of ways. Okay, stack can be implemented. Okay, so by using first thing we can also do we can also implement by using arrays. So if you talk about C language, okay, so generally in the C language will normally will implement either by using arrays or linked list. Okay, so we can also implement stack by using arrays, or we can also implement stack by using linked list. Okay, so if I talk about in Python, okay, so we can also implement stack by using a list. Yes, so stack can be implemented either by using arrays or linked list or list. It's your choice. However you want to implement it, you can implement. Okay. So, but what would I suggest you is nothing but so whenever you're writing a program by using a Python, okay. So I would suggest you to go with the list. Okay. So why I'm suggesting you or why I'm asking you to go with the list whenever you're asking, whenever you're writing a Python, because we have a lot of inbuilt functions on lists. Yes. so which can be used to build a stack easily. Okay. So and one more thing, everything either stack or queue or linked list, circle linked list, whatever it is. So every time we will make it as a class. Okay. So what is the use of making it as a class? Yes. Okay. So here comes the importance of this oops. Okay. So because if you observe, if you make it as a class once, you can create n number of stacks. Okay. So how can you create n number of stacks? Okay. So we can create n number of stacks by creating n number of objects for those respective stack. Okay. So stack can be implemented either by using arrays or by using list. Okay. So coming to linked list. Okay. So how can we implement stack here? By using linked list. Okay. So here it can be implemented in two ways. Okay. So I'm just writing it here. 1 minute. Give me 1 minute. Okay. So one way is what? So one way is doing with. So whenever you want to implement stack by using linked list, okay. So do the insertion and deletion operations at the same end. Okay. So for example, you can make it like insert at end. Okay. So generally, what are the main operations you'll be having? Push. Okay. So for the push operation, what you can do in the linked list? Okay. So you can do insert at end. Yes. Okay. And for the pop operation, okay. And for the pop, what can we do? Yes. So tell me, for the pop operation, I should do delete at end or delete at beginning. Yes, guys, we have discussed yesterday. So I'm expecting answers. Yes, for the for the pop operation, what we need to do? Exactly, Srinivas. Yes. So if you are doing insert at end, so whenever you do insertion and deletion at the same end, it acts like a stack. Yes. So we need to do delete at end. So this is one way of implementing stack. Okay. And we can also implement in one more way. Okay. So by using linked list. Okay. So yeah. So for push operation, yes. Okay. So for push operation, what can I do? Okay. So for push operation, I can do insert at beginning. Yes. Or you can also do for pop operation. Okay. So for pop operation, you can also do what can I do? So delete at the beginning. Yes. Okay. So delete at beginning. So this can be done uh, by using linked list. So I hope you all know how to perform insert at the beginning and how to perform insert at end, delete at end, insert at beginning, delete at beginning, because we have discussed this for an entire day. For 3 hours, we have discussed only single linked list. Okay, so why I have spent that much of time? Because it is kind of an important, so we'll be using almost the same thing in all the things. That's why I've spent a lot of time on this linked list. Okay, uh, fine. This is implementing a stack by using a linked list. Okay, so now how can we implement this stack by using a list? Okay, so we have a list in Python, so directly we can use this stack. Sorry, directly we can use this list. Okay, so even here, okay, so if we observe, yeah, so yes. So coming to this one, so even by using list, we can perform it in two ways. Okay. So mainly I'm discussing push and pop here. Okay. So for push operation, what can we do? Okay. So for push operation, we can use a function called append. Yes. For push operation, we can do a thing called append. Okay. So and then for pop operation, tell me what can I do? So append is what? Append is insert at end. Yes, append is a method of a list. So I'm putting it inside a bracket. Okay, so append is a method of a list. Okay, so we always insert an element at the end. So if you want to make this list to work as a stack, okay, so what should I do? If I am doing insert at the end, then I should also delete. So whenever I ask you to delete an element, I should delete an element at the end. Okay, so tell me what is the method which will be used to delete the last element? Exactly, Nandini. Okay, so we have discussed this yesterday. Yes, okay. So we have a method called pop. So directly we can use this method called pop of a list. Okay, so this is insert at end and delete at end. Okay, so and same thing we can also perform by using insert at beginning and delete at beginning. Yes, okay. So for example, if I want to insert an element at the beginning, so tell me what method I should use in a list. Append actually, what it does, append always what it does, append always adds an element at the end. Now I want to insert a method at the beginning. So insert a value in the list at the beginning. So tell me what method I should use. Yes, we have discussed all the methods of list. So when we are discussing Python basics. So tell me what should we use? What method we should use? Okay, so exactly. Okay, so what method we should use such that I can insert a value at the beginning? Yes, so we have a method called insert. Okay, so we have a method called insert. Okay, so insert. Okay, so what about this insert? Okay, so insert is a method of a list. So which uh, okay, so which adds an element at respective position at what you can give any index value. Okay, so whatever the index value you mention, so at that particular index, your value will be inserted. So I'm writing insert of 0 comma x 0 comma. So for example, I'm writing value. Okay, so yeah. So if you observe, whenever you want to insert an element at the beginning, then tell me what should I do? I should use insert 0. So first argument represents here position, and second argument represents the value which you need to insert. Yes. So it will do this operation. Okay. So what is this? This is insert at beginning. Okay. So next pop. Okay. So tell me, for pop, what should I do? So if I'm doing insert at beginning, obviously I should delete an element at the beginning. Yes. Okay. Then tell me, do we have any method? Okay. So do we have any method which deletes the first element? Yes, guys. So do we have any method? Okay. So do we have any method which removes the first element? Yes. Do we have any method? Okay. So do we have any method which deletes the first element? Uh, yes. Okay. So as guys, what can we do? Uh, exactly. Okay. So yes, Abhinay, we can use. So if you observe pop, so coming to this method called pop. Okay. Yes. Okay. So yeah, some people are telling, giving answers like do slicing. Okay. So if you do slicing, it creates one more list. Okay. So I don't want to create one more list. I just need to delete an element. So again, creating a one more list and again assigning it number of list. So many number of lists will be created. Okay. So delete 0 comma value. No, it will not work. Yes. Okay. So in which it should delete. So if you write less list name, so delete will almost delete the entire list. So what we can do. So coming to this pop method. Okay. So pop is a method. If you don't mention any index, it will remove the last element. If you want, you can also mention the index. So I'm writing pop of 0. Yes. So this method called pop of 0 removes the first element. Is Srinivas and Abhinay we can directly use. So instead of doing slicing and then instead of doing delete, okay. So we can directly do pop of 0. Yes. Okay. So after then, yeah. So if you want me to explain for pop operator for peak, okay. So for peak, what will we do? So this is insert and delete. Okay. So for peak, actually we have discussed yesterday. Okay. So fine. As I've told, it is kind of a revision. Okay. So we'll see now. Okay. So this is for push and pop. Done. Okay. So now we'll see for peak what can we do. So peak, what peak should do? Peak should always give me the last element. Yes. Peak should always give us the last element. Should give us the last element. Okay. So what am I doing? So for peak, as it is a list, I can directly get the last element. Yes. So how can we get the last element? So if I take self dot, so if I take a, so self dot a of -1. So this -1 directly gives us the last. Okay. So coming to peak, peak does not remove the top element. Yes. Some people are telling remove the top element. No, peak does not gives the top removes the top element. It will just give you the top element, topmost. Okay. So I'm just accessing self dot a of -1. If I take a as a list, okay, that is how peak works. Okay, and then coming to what is one more thing? Yeah. Okay. So and then length. For length directly, length of a stack. So we can directly use a method called len. So which is available for list inbuilt method. Okay. So length of self uh, dot a of I. Sorry, self dot a. Yes. So that will directly give the length of the stack. Okay. Next for displaying. Okay. So for displaying, what we need to do? So we cannot go with the slicing. Okay. So we need to find the length of the list. Okay. So and then print it from reverse. Okay. So yes. Okay. So this is about stack. Yes. Okay. So yeah, guys, this is about stack. Okay. So still, if you have any doubts in stack, please ask me. So if you don't have any doubts in stack, okay. So I want next discuss about queues. QUEUE. Okay. So if yes, guys, if you have any doubts in stack, please ask me. Okay. So yeah. So coming to queue. So I'm not getting any question. So believing that you have understood everything. Okay. So I'm going with the next thing. Okay. So for queue, we'll write a code. Don't worry. Okay. So for stack, we have already discussed yesterday. So I did not write the program. Okay. So actually now I have told you everything. You should tell me what we should do. Okay. Now you should write the code and send me. Okay. So fine. First, before writing a code for queue, okay. So we'll see. Yeah. So if stack is last in first out, okay. What about queue? Exactly, Srinivas. Okay. So Q is nothing but yes, Nandini, we can tell it as first in, first out. So whatever the element goes first, okay, so that comes first. It's like you might you yes, Abhinay, speaker is on. If you don't have any doubt, mute yourself. Yeah, thank you. Okay. So you'll have a lot of applications of queue just standing in a queue before cinema theater where you're taking ticket. Okay. So whoever enters into the queue first, okay. So that person will take ticket first. That person will get the ticket first. Yes. Okay. So yeah. So either I can write tell it as first in first out, or also I can tell it as like last in last out. It's both the same only. Either first in first out or last in last out, both the same only. Okay. So next. Okay. So yes, guys. So what are the queues operations? So what are the operations we'll be doing on queues, or what are the technical terms which we'll be using mainly on queues? Yes. Yeah. So exactly, Lakshmi. Okay. So what are the things we'll be using? We'll be using NQ. Okay. So NQ and then DQ. Okay. So QUE, UE, whatever it is. So I'm just writing N, EN, QUE. Okay. So UE, UE. Okay. So and then front. Okay. And rear. Front and rear. Yes. Okay. So these are the main operations we'll be doing on queues. Okay. So after then, if you want to find the length of the queue, if you want to add all those things, yes, you can add. So these are the main operations. Okay. So NQ, DQ, front, rear. Okay. So what is an NQ? What is an NQ operation? Okay. So NQ operation is nothing but inserting an element into queue. Yes, or adding an element into queue. Okay. So inserting an element. Yes. Okay. So and then coming to DQ. So what is a DQ? So DQ is nothing but deleting an element. Okay. So DQ is nothing but deleting an element. So I'm just writing it. Uh, Deleting an element. Okay. Next. What about front? Okay. So what is this front? Yes. So what is this front? Okay. So front always gives you the first element. Yes, first element. Okay. So point. So front always gives you the first elements, or it will be pointing to the starting element of the queue. Okay. So rear will always be pointing to the ending element of the queue. Yes. Okay. So or yeah, I'm just writing points to the first element. Points to the first element. Okay. So and then coming to rear. Okay. So points to last element. Points to last element. Okay. So and then coming to length. So what about this element? So length of the queue. Okay. So these are about queue operations. Yes. Shailu, your speaker is on. If you don't have any doubt, please mute yourself. 18551, Shailu. Yes, fine, fine. Okay. So, and one more thing, if you have not renamed yourself, please rename now, everyone. Pawan Kumar Chopra, Nitisha, Mallika. Yes, yes, guys, rename yourself. Yeah. These are about queue operations. Okay. So, and again, So in the same like this queue operation, so this queue can be implemented again three ways. Yes. So normally, so this queue can be implemented again in three ways. Q, U, E, U, E. Okay. So queue can be implemented. Okay. So in three ways or in these ways. Okay. Can be implemented by using. Okay. So we can do by using arrays. Okay. So or we can also do by using linked list. Yes. Or we can also do by using list. Yes, actually in Java we we can implement by directly by using collections. Okay, so yeah, here we don't have anything inbuilt, so we just need to create it. Yeah, so if you want, you can also implement queue by using stack. Yes, so using two stacks, we can implement queue. Yeah, so but yeah, that is kind of an application of stack. Okay, so but mainly standard. So generally we'll use these three. So arrays, linked list, and then list. Uh, yes. Okay. So if you want, we can also implement by using stack. Okay. So but we need two stacks. Okay. So we'll discuss that. That is actually a question. Okay. So fine. So first, so coming to here, so NQ operation. So how can we implement in two ways? So even here, linked list. If you want to implement by using linked list, so we can implement it in two ways. Okay. So NQ operation. Okay. So again same. So previously for stack, what did we do? We did insertion and deletion at same end. Okay. So but for queue, what do we need to do? Yes. So what we need to do? We need to do insertion at one end and deletion at one end. Okay. So normally, queue, what we will insert. Yes, we need to at different ends we need to implement. Okay. So generally, we'll do insert at end, delete at beginning. Normal queue. Okay. So if people are standing in a queue, so we'll enter at the end, we'll come out at the beginning. Okay. So so first I'm writing traditional one. Okay. So insert at end. So if you want to implement by using linked list, okay. So we can do insert at end of NQ. Okay. So and okay. So for DQ, okay. So for DQ we can do okay. So for DQ we can do 1 minute. Just give me 1 minute. Okay. So yes, what we can do if it is that inserted end, so this should be deleted beginning. So in order to implement this queue by using linked list, we need to perform at different ends. Okay. So this is one way of implementing queue by using a list. Okay. So yeah. Next, we can also implement it in one more way. Okay. So yes, guys. Just give me 1 minute. Just give me 1 minute. It's an important call. Just give me 1 minute. 1 minute, guys. Yeah, fine. Okay. Uh, okay. Whoever is 540, I did not ask to send your roll number. Send your roll number whenever I ask you, and along with your roll number, please send your name also. Okay. Next time, when I ask you, so send your numbers only at the time. Okay. Fine. So yes, this is about yeah. So coming to this linked list. So if you want to implement a queue by using a linked list, so we can also do it in two ways. Okay. So previously it was insert at end. Okay. So now what we can do? So we can do insert at beginning. Okay. So and for DQ, what we can do? So we need to do delete at end. Yes. So insert at beginning and then delete at end. Yes. So in these two ways we can perform or we can build queue. Okay. So by using linked list. Okay. So and then yeah, how can we implement a queue by using okay. So by using list. Okay. So what are the operations? These are all the operations, right? NQ, DQ, front, rear, and length. Okay. So now let us build a queue. So let us write a program. Yes. Okay. So and whenever I'm writing, so you should send me. I'll just write down what are those methods. So you should tell me those methods definitions. Okay. So yes. So we'll just write a code for implementing queue. Okay. So by using a list. Okay. So every time. So whenever a whatever the thing you're writing, we'll make it as inside a class. Okay. So why inside a class? Because okay. So we can create n number of queues. So I'm creating as a class. Okay. So here we are implementing it by using a list, right? Okay. So for that reason, okay. So every queue. So here, so whenever I create an object for this queue, I need a list to be created. Okay. So for that reason, what am I doing? I'm making that list as an instance variable. Okay. So I want to make a list as an instance variable. Okay. So why I'm making this as an instance variable? So I'm just using it as self.a. Okay. So here a is an instance variable. Okay. So why I'm making a list as an instance variable? Because so whenever I create a queue, so whenever I create a queue, I'm implementing a queue by using a list, right? So whenever I create an object for queue, okay. So for example, okay. So let me take the end. So for example, if now I'm creating an object for queue, okay. So let me take my object is queue, okay. So queue is an object, okay. So or if you want to take some more variables, so I'm taking uh, z as my queue. Okay, so z is equal to, I'm just creating an object for queue. So whenever I want to create an object, I should write class name and then these brackets. Okay, so now what happens? So whenever I create queue, okay, so if you observe, this list will be created. Okay, so why I need a list? Because I am implementing queue by using a list. Yes or no? Okay. So yeah, so for that reason I'm making it as an instance variable, so that that list will help me to create a queue. Okay. So now let us see some methods. So what are those methods? Methods are enq, enq, ue, ue. Okay. So enq. Okay. So fine. I'm not writing anything. So for example, okay, so every method should have a self. Okay, I need to insert a method. I need to insert a value, right? So I'm sending X. Okay. So everyone, now send me what should be the definition for NQ. Yes. So everyone first tell me what should be the definition for NQ. Okay, and what you need to do. So write firstly. Okay. So first we'll see this. So now NQ should be inserted end and DQ should be deleted beginning. First we'll write a code for this inserted. We can do either in two ways, either do inserted end or deleted beginning, or inserted beginning or deleted end, anything is fine. Okay, so but traditional one is what? Inserted end, deleted beginning. So first I'm implementing this thing, so later if you want we can change it. Okay, so now whenever I ask you to write a code for NQ, do inserted end and DQ deleted beginning. Yes, guys. So tell me what I need to my what should be my NQ definition. Okay, and also for DQ, UE, UE. Okay. So for DQ we don't need any values. I'm just writing self. Okay. So here I'm not writing anything. You should tell me. Yes. Okay. So pass. Next. Okay. So everyone try these methods NQ and DQ. I have explained what you need to do. Okay, so when I was explaining stack, have explained the methods which we can use for that purpose. So everyone send me the code. Yes, Sadhana, Meghana, and 5D6 are sending code. Yes, very good. Remaining people try. Front. What about front? So this front should return a value. Yes. Okay. So front should return the first value. Okay. So write down what should be my method definition for front. Okay. So and then rare. Okay, so rare of self, so it should return uh, last value, rare value. Okay, so and then uh, yes, Meghana, yeah, a queue is a collection of entities that are maintained in sequence. Yes, any doubt with that? Yeah, you have sent a definition of a queue. If you have any doubts, please ask. If not, yeah, fine. Fine, no issues. Yes. Okay. So if not, try for front and rear. For front, whenever you call a method called front, it should return the first value. So whenever you call it as a rear, whenever you call a method called rear, it should return the last value. Yes. And one more thing, what do we have? And one more thing, we have a method called length. Okay, so length, so default parameter should be self. Okay, so I'm making it as a self and then pass. Okay, so you people should give me the definitions. Yes, very good. Some people are responding. Okay, so what about the remaining? So everyone try and send me the code. So if you're just listening, you'll not understand anything. So you should start writing. Actually, it would have been very good if it was a normal class, but because of COVID, it's not possible. So if I were in class, I would have made everyone to write. Okay, now you should be active and you should send me the codes. Yes, guys, I'm not asking big lines, so it is all just take one line or two lines. Okay, and one more thing, we should also have display. Yes, so display. So this display should mention all the codes. Sorry, all the values. So what should I write for display? Okay. So after, so you people try all these codes for NQ, DQ, front, rear, length, display. Okay. Yeah. Next. Okay. So So now what am I doing? Okay, so first, so what about this queue? They are telling. So first, let us take. They are giving n number of elements, so which they want to insert inside a queue. 10, 20, 30, 40, and 50 are the codes. Yes. Okay. So or the elements which they want to insert. Okay. So first, what am I taking? First, I'm taking n value. Okay. So n is equal to int of input. Okay, that means how many elements I want to insert. So after that, what am I doing? I'm taking a for loop. For yes, guys, 5d6 is very good. Okay, so 502, yes. Srinivas, yes, good. Yeah, people are sending code. Try it and send. Okay, so I'm writing for I. I'll check all the codes. Don't worry. So if there are any mistakes, I will tell you. Okay, so for I in range. For I in range of n. Okay. So what I need to do, I need to insert, right? So for inserting operation, what I need to do, I need to do enqueue. Okay. So for that reason, I am calling z dot enqueue. Ue. Okay. And what element I want to insert an element called x. Okay. So first, if I want to insert an element, I should take an element. Okay. So for that reason, I'm writing x is equal to int of input. So yeah. So after then, whatever the methods you want to call, you can call all those methods. Okay. So for now, I'm just calling display queue. Okay. So for that, I want to use object name dot its method. So what is the method? Display. So first we'll see this thing. Okay. So after then we'll go for the all the method definitions. Yes, guys. Yeah. Yes. Yes. 5d6 actually very good. You have sent everything. Okay. Is 502 Nandini, Madhav. Yeah, at least people are trying. Sadhana, 502, 5d6, Srinivas. Yes, very good. Okay. So now we'll see. So coming to this insert at end, coming to the NQ, we need to do insert at end, right? Yes. So we need to do insert at end. Okay. So what am I doing? So I'm just calling self dot a dot append. So we have a method called append. So directly use a method called append. Append of what? I need to give an element also, right? So I need to write append of. So I'm just giving append of x. Okay. So next for DQ. So for DQ, I need to delete an element at the beginning. So we have seen actually we can write delete a of 0, delete of self dot a of 0, or we can directly use pop. I would suggest you to go with only one method. Okay. So that you'll not get confused. Okay. So just I'm writing self dot a dot pop of 0. So for pop, if you give index value, that will delete that particular index ka value. Yes. And then coming to front. Yes. So coming to front first. Okay. So for front, I need to give front element. Yes. Okay. So exactly. So whenever you ask for front element, actually you need to check whether there is a list or not, or whether there is a queue. Do we have any element in queue or not? Yes. Okay. So for that reason, what am I doing? So first, I'm actually checking. So if length of the queue is not 0. Yes. Okay. So if the length of the queue, that is, if there are any elements in the queue, then only I can return. So if there are no elements in the queue, I cannot return anything. Yes. So for that reason, uh, actually I'm checking here. If if okay, so if you want to call length method, you can directly call length method, or if you just want to use length of, and people whoever is writing, so they are missing self. Okay, so remember, so whenever you are using an instance variable, you should always use self. Okay, so 5d6 you have written code but you have never used self, please take care of that. Okay, so 1 minute, I'm checking all the codes. Yeah, Sadhana, fine. A of -1 self should be included because it is an instance variable. Yes, Srinivas, good. You have used self. And again, 5d6, you need to use self. Yeah, Sadhana, fine or two. Everyone used self. Fine. Yeah. Okay. So first, I need to check length of self dot a. If it is equal to 0, then what should I do? I need to print what? So for example, I am printing queue is empty or no elements in queue, whatever you want. Okay. So for example, if you want to print queue is empty, so one of your friend has sent this type of code. So I'm just writing same thing. Okay. So queue is empty. I'm writing queue is empty. Else, that means if length is not 0, I have written is equal to 0 here, but that should be written outside because length of self dot a will return, right? Yeah. Okay. So length of self dot a is equal to 0, then queue is empty. Else, I should return some value. So if you want to return a value, we need to use a method called return. Okay. Return what element I should return, as it is the list self dot a of first element 0. So return a of 0. Yes. So coming to rare also I'll do the same thing. So if the list is not empty, sorry, if the queue is not empty, that means there is a possibility of having a rare element. Yes. Okay. So I'm just writing the same thing. I'm copying the same thing. So for rare, what am I doing? Okay. So same thing almost. So if length of self dot a is equal to 0, queue is empty. Else, what should I return? I want the last element. So here I can directly use negative indexing to get the last element. So I'm just using length of a of -1. Okay. So even for length. Okay. So even for length. Okay. So length always should return a value. Yes. So length should return a value, right? Okay. So I'm writing return. Okay. So return length of self dot a. Yes. So this will does this length operation coming to display. So even when I ask for display, what I need to do first, I need to check whether list is empty or what. Okay. So after checking if the list is not empty, then only I can display the elements. Yes. If the list is empty, I cannot do anything. So if length of self dot a is equal to 0, queue is empty. If not, I need to print all the elements. Yes. So if you need to print all the elements, you can just use, I cannot use print of self dot a. Okay. So if I use print of self dot a, it will print all the elements with the brackets. Okay. So if not, if you don't want this, actually can use for loop or directly we can use star. Okay. To find those, that part will come to later. So I'm just writing for I. Okay. So if you want to print by using indexes, then you need to find out the length. If you don't want print by using indexes directly, you can use this iterator for I in self dot a. Yes. So for I in self dot a, print I. Yes. So this I loop will start from the first element until it goes to the last element. Yes. So now this is about queue. class called queue. So I've created an object, took n variable, that is nothing but n inputs. Okay, so x and then z. Yeah. So now let us check whether it's working or what. Okay. So I'm executing. 1 minute is showing an error, has no attribute called display. So I think I've made some spelling mistake. Yeah. I've written as display. It is display. Yeah. So I'm getting 10, 20, 30, 40, 50. Yes. Okay. So after this, let us delete an element z dot dq, dequue. Okay. So after this, I'm just writing. Okay. So for example, after dequeuing an element, deque. Okay. So after dequeuing an element, okay. So and then I should display z dot display. 1 minute. Z dot display. Okay, let us check. So yeah, so if you observe first 10, 20, 30, 40, 50, so if I'm doing DQ, so 20 got deleted. Sorry, 10 got deleted, first element. First in, first out. So first element was 10, which I have inserted. So when I'm deleting, first 10 got deleted. Okay. So now let us check all the methods once. Okay. So yeah, so I'm just calling front element. Okay. So yeah, let us check. So let us call that z dot front. What will be the front element? 20 will be the front element. So if you observe, I have written end is equal to double colon. That's why I got front in the same line. Okay. So now let us print the rare element. Just copying. Okay. So I'm just writing rare. Okay. So rare element, I just need to call z of rare. Yes, my rare element should be 50. 50 is the last element. Okay, so rare element is 50. Okay. Next, next, what are the methods we have used? Display we have already used, just length. So I hope everyone knows. Uh, we'll also get the length. Okay. So, but let me check. Okay. So I'm just using length. So after deleting an element, my length will be 4. So I'm just calling z dot length. ngth. Yes. Okay. So length is 4. Yes, guys. This is about queue. Implementing a queue by using a list. Yes, guys. If you have any doubt, please ask. If you have any doubt in the stacks and queues, please ask. Okay. So yeah, this is insert at end and delete at beginning. Okay. So we can also do insert at beginning, delete at end. For that, what you need to do? Okay. So you need to write insert of 0 comma x and then just pop. That's it. Okay. Guys, now the time is 11:35. Okay. So we'll take a break. Okay. So before going for a break, everyone send your roll numbers in the group. Yes, everyone send your roll numbers in the chat box, and we'll meet at 11:50. So after the break, we'll see trees. Along with your roll numbers, send your names also. Okay. So let me check chart in the YouTube. If you have any doubts, please post it Uh, yeah, guys, let us start the session. Okay. So, yeah, now we'll see trees. Yes, can anyone tell me what is a tree or what you know about trees? Uh, uh, yes, 540. What is your name? 540. 18891A0540. Nishant. Okay, Nishant. Yes, correct. Okay. So, yeah, Nishant. So, obviously, trees will not have any loops. Yes. Okay. Uh, yeah. Non-linear data structure. Yes, we can also call it as non-linear data structure. Okay. So, yes. And any other things you know about trees? Only two people have responded. Yes, trees will have node and then children. Yeah, collection of nodes. They may have direction. Will trees have directions? Okay. So first thing, why should we learn about trees? So first we have seen why we have learned about linker list. Okay. So linker list because so normally okay. Uh, yes, Lakshmi Sundari have raised hand. Any doubt? Okay, fine, fine. If it was by mistake, no issues. Okay, so fine. So first, yeah, we'll see about these trees first. Okay, so I'm just writing what are the things you have mentioned. Yes. Okay. So coming to tree, what can we tell? Yes, we can tell it as non-linear data structure. Yes. Okay. So it is nothing but non-linear data structure and okay. So and let us see. Yeah. So you're telling we'll have no loops. Uh, I'll tell you what is the meaning of containing a loops. Okay. So will not contain loops or will not have loops. Okay. So yeah, consists of nodes. Yeah. So consists of nodes which are connected by edges. Which are connected by edges. Okay. And what are the things? Yeah, you can also tell collection of nodes and any other things. Yes. Okay. So exactly. Yes. Yes. Yes, Adana. We'll discuss that point. Okay. So coming to this, before discussing about tree. Okay. So I hope everyone knows what is a tree, but I just want you show the pictorial representation once. Okay. Yeah. So coming to this tree, so yeah, so first thing it will have root node. Okay, so tree, so every node, so normally it can contain any number of nodes. Okay, so for example, so starting node or is called as a root node. Yes, okay. So for example, here I'm just taking one node, 10, 20, 30, 40. Okay, and it can have some more nodes. Okay, I'm just taking some random numbers. Okay, so it can also have single nodes. Okay, so yeah, so if we observe here, so if you observe, this is called as root node. I purposely taken more than two nodes because a tree can contain more than two nodes. But generally, we'll go with binary tree. Okay, so we'll discuss what is a binary tree, all those things. But normally, okay, so the starting node is called as root node. Okay, and it can have n number of children. Okay, these are called as child nodes, and the last nodes are called as leaf nodes. So, for example, all these things. Okay, so the last one are called as leaf nodes. Okay, let me delete this. Okay, so the last nodes are called as leaf nodes. So if you observe, it is called as non-linear data structure because nodes will not. So if you observe what are the linked list, arrays, list, okay. So stacks, whatever you have seen, they are like kind of single line, linear. Okay. So trees, I cannot tell that they'll have some particular direction. So it can have n number of nodes with n number of children. Yes, linear data structure. Okay. And one more thing. So what is the meaning of it will not have any loops? So if you observe here, so nowhere these nodes are forming a loop. Yes. So here I don't have any loop formation in this tree. So if you observe, this will never have any loops. Okay. So for example, what is a loop? So what I was trying to tell. Okay. So for example, if I hope you understood what is your leaf node. Leaf node are nothing but the last nodes. Okay. So if you observe, so what I was trying to tell loop is nothing but, so for example, if these two are connected, so if you observe, this forms a loop now. Okay. So 1 minute. So let me take easy thing. Yeah. So 35 and 6. So if these two are connected, 5 and 6 are connected, then 35, 6 forms a loop. Okay. So observe one thing. So trees will not have loops. Okay. And graphs will have loops. Okay. So I can tell if a tree contains a loop, that becomes a graph. Okay, so graph is the next concept which we'll be discussing mostly tomorrow. Okay, so yeah, so first thing I can tell is a non-linear data structure. Okay, so it will not have any loops. Consists of nodes which are connected by edges. Okay, so if you observe, all these are nodes. Okay, this is a node. This is a node. Okay, so all these are nodes, and what about the edges? So these connections. Okay, so lines which are connecting those two nodes are nothing but the edges. Okay, so yeah, and here the bottom nodes are called as leaf nodes. Okay, so this is about like normal thing about trees. What are leaf nodes? What are edges? This one is nothing but a root node. Okay, so edge. So edge is nothing but what is an edge? Okay, so link between two nodes. Okay, so link between two nodes is nothing but an edge. Okay, so what is a leaf node? Okay, so leaf node is what? Okay, so I can tell a node which is not having any children. Okay, so a node with no children, or the bottom nodes. Okay, the node with no children. are called as leaf nodes. Yeah. So parent nodes. Yeah. If I'm talking about leaf, I should also call about parent node. Okay. So what is a parent node? Parent node is nothing but a node with children. Yes. Okay. So parent node is nothing but node that has an yeah, node that has an edge. Okay. So to a child node. Okay. So for example, here 10, 20, 30, 40, 10. Okay. So all these are parent nodes. So this 10 has three nodes, 20, 30, 40. Okay. This 30 is also parent node, 5 and 6. This 10 is also parent node, 20. So this 40 is also parent node. Yes. Okay. So if you observe any node which is having a child, okay, so it's called as parent node. Okay. So and if I'm talking about parent, I should also talk about child node. Yeah. So what about a child node? Okay. So child node is nothing but a node that has a parent. Node which has a parent. Which has a parent is called as a child node. Yes. Okay. So let's find next. What is the meaning of height? Height of a tree. Okay. And depth of a tree. Yes, guys. Anyone? What is the meaning of height of a tree and depth of a tree? Yeah. So yeah, exactly, Sadhana. Height is nothing but length of a longest path to a leaf. Okay. So length of the longest path to a leaf. Is yeah, or I can tell number of edges. So path is nothing but edges. So for example, here, so here can tell what is the height of a tree in this example. What is the height of a tree? What is the longest path here? Yes, guys. What is the height of a tree here? So yeah. So here height of it is nothing but the longest path. What is the longest path from root node to the leaf node? So if you observe this thing, so 10 to 20. Okay. So 10 to 20, 40 to 10, and 10 to 20. So what is the height? Height is nothing but 3. Yes, number of edges. Okay. So 10 to 40, 40, 10, and 30. So height is nothing but 3 here. Yes. Okay. So and then coming to the depth. Okay. So depth. What is the depth? Depth of a node. For example, like, give me 1 minute. Okay. So if I talk about depth of a node, what is the meaning of a depth of a node? Okay. So depth of a node is nothing but the length of. Okay. So depth of a node is nothing but depth of a node is, yeah. Okay. So yeah, depth of a node is nothing but length of the path to its root. to its root. So if you observe, height is from root node to the leaf node. Okay. So and then depth is from that particular node to the high root node. For example, what is the depth of 5? If I take this 5, the depth of this 5 is 2. 5 to 30, 30 to 10. Yes. So depth of a particular node is the of this 5 is nothing but 2. So 5 to 30, 30 to 10. It is not from that node to its root. Okay. So and okay. Uh, yeah. Coming to this, why should we learn about these trees? Yes. Okay. So the main thing is nothing but, so if you observe, if you take, so why did we learn about linked list? Because insertion deletion operations is very difficult normally in arrays. Okay, so that's why insertion and deletion becomes very easy in lists. Okay, so coming to this list, so in the list, searching operation and sorting operation becomes very difficult. Yes or no? Okay, so for example, so 1 minute. So let me take one list. Okay, so if I have a list is nothing but linked list. Okay, so for example, if I have some elements called 10, 20, 30, 40, 50, and so on, let me take, there are 100 elements. Okay, so if you want to search an element in this, so if you go with the linear search, you need to do 100 operations. Even if you go with binary search, log of n operations. Okay, so if you observe search, again sorting, so if you observe, if you implement binary search, okay, so your time complexity will be very big because there are a lot of elements. Okay, so the same thing if you take a tree. So if you observe, searching and sorting operation becomes very difficult in list. Okay, so and that will be very easy in trees. Okay, how? Okay, so for this actually we have something called binary search tree. Okay, so we'll discuss about this binary search tree. Okay, so but now I'll just give an idea. Okay, so for example, if I take some, this is a root node called 50. Okay, so always in the left side. Okay, so the left side what will have, so whenever I'm forming a tree, okay, so the left side will have a value lesser than this 50. Okay, so for example 30 here, so here for example 70. Okay, so and again same, so same thing I should follow for every node, a node whatever the node you take. Okay, so the left side node should have a value lesser than this parent node, and right side node should have a value greater than this parent node. Okay, the same thing should be done for this 30 also. Okay, so for example here I should have a value lesser than 30, so I'm taking it as 20. Okay, and here greater than 30, uh, and it should be obviously less than 50. Okay, so and I'm going with 40 or 46, whatever. Okay, so here less than 70 and greater than 50, so I'm going with 60. And here okay, so less than 70, greater than 70, so 1 minute, so I'm going with 80. Yes. Okay, so for example guys, so here if I want to find the smallest element here, so if I want to find the smallest element in this binary search tree, so tell me what should I do? Yes, if I want to find the smallest element in this tree, so tell me what should I do? So 68. Yes, any answers? Anyone from CSC? So if I want to find the smallest element in this tree, okay. So if we observe, what should I do? Obviously, yes. Okay. So if I want to find the smallest element, I should find the last node in this. So if you observe, if I want to find the smallest node, I should go with this uh, leftmost node. So if you observe here, 20 will be only the leftmost node. Okay. So if you observe here, the number of iterations will be very less. So generally, how will you search? So It is very easy, right? So for example, if I'm searching for 20, or if I'm searching for 30, okay, so I'll just compare with this root node. Is my 30 is greater than 50 or less than 50? Less than 50. So compare only right. You need not compare in the left total left node. Yes, and again say, so if you observe just here, if you want to find smallest node, you just need to do only 2 iterations. Yes, okay. So what is that? So comparing here 1, 2. So third one you get the answer. So for the largest element, so in order to find the largest element, you need to find rightmost element. Yes. So rightmost element with no children, or rightmost leaf node. Here for the smallest element, leftmost leaf node. Yes, and even for sorting also. Okay, so for sorting you need to do rotations. Okay, so even sorting becomes easy when compared to the linked list. Okay, so that is why actually uh, we'll be using these trees. Okay, and it also has a lot of applications. Okay, so like same trees will also be used. Okay, so for example, if you want to find the shortest distance, how this Google Maps works. Okay, so actually is a graph. Okay, so in the graph we'll be finding minimum spanning tree. Okay, so by using spanning tree we'll find out the shortest distance between the two places. Okay, so all those applications we'll discuss. Okay, so for now I just want to so in this class we'll just learn. Okay, so how to build a tree. Okay, and what is it traversal? So how can we traversal? Okay, so in detail, programs, all those things we'll be having again training on data structures and algorithms. Okay, so at that time we'll discuss. Okay, so for now, we'll just learn building a tree and then traversing a tree. Okay, so yeah, so what is the meaning of traversing? Traversing a tree is nothing but going through each and every node. Yes. So traversing a tree is nothing but going through each and every node. Okay. So and then coming to tree traversal. So are there any types of traversal or tree traversal? Okay. So DFS and BFS are for graphs. Yes, I hope Nishant. Okay. So BFS binary first search and depth first search or the traversal techniques which will be used for graphs. Okay. So this is trees. So in trees we'll not use BFS and DFS. Exactly, Karthik. Okay. So what will we use? We will be using pre-order, post-order. Okay. So pre-order, post-order, and in-order traversals. I'll discuss what is this pre-order, what is this post-order, and what is this in-order. Don't worry. Okay, I just want you people to know that in these three ways we can traverse a particular tree. Okay, traversing a tree is nothing but accessing each and every node. Okay, yeah. So before this, we'll see types of trees. Okay. So are there any types of trees? Actually, we have discussed now one tree. Okay. So what is that? We have a binary tree. Yes. Okay. And we have binary search tree. Yes, guys. Any trees? Okay. And we have normal tree with any n number of rows. Okay. So yeah, spanning tree. Fine. Okay. So and then AVL trees. So we also have red black tree. There are a lot of trees, but these are kind of important. Okay, so what about binary tree? Okay, so what about binary tree? Binary tree is nothing but it can have maximum of how many children? Yes, binary tree can have maximum of how many children? Exactly. So this binary tree can have maximum of two children. Okay. So I'm telling maximum of two children. That means it can contain one, zero, or two. Okay. And for binary tree, we don't have any conditions that left part should be lesser than, right part should be greater than. Okay. So for binary search tree, these conditions should be followed. Okay. So left node will have lesser value. Okay. So and then right node will have a value greater than parent node. Okay. So yeah, and coming to this binary tree, we'll also call it as left child and right child. Okay, because it will have only two children. Okay. So binary tree can have maximum of two children. Okay. So but here, so if you observe, this is a binary search tree. I have written BST. So here there are conditions like left node should have a value lesser than its parent node, and right node should have a value greater than its parent node. Or left subtree, right subtree. So if you observe, I can call left subtree should have lesser values and right subtree should have greater values when compared to this node. Yes, Bhavna, your speaker is on. Do you have any doubts? Yes. And one more thing in binary search tree. So this condition should be followed. Okay. And also no duplicates. Duplicates will not be there in binary search tree. Okay, duplicates is nothing but will not be having a node, two nodes with the same value. Yes, uh, duplicates are not allowed. Okay, and what about this AVL tree? Okay, so any idea about what is this AVL tree? Actually, what is an yeah? So, do you anyone from CSE department? What is an AVL tree? Okay, so exactly. Okay, so exactly, Soundarya, we can call it as self-balancing tree. Okay, so what is the meaning of balancing? Or if you want to call it as self-balancing binary search tree, BST. Okay, so why it is called as ABL? Okay, so it is based upon their creators who invented this tree. It is Adelson, Welsky, okay, and then Landis. Adelson, Welsky, and Land based upon their inventors. So it was named as ABL tree. It is called as self-balancing tree. Okay, so what is the meaning of self-balancing tree? Any answers? Okay, so what is the meaning of self-balancing tree? Uh, exactly. Yes, yes, yes. Okay. So if we observe, if I take this tree, okay. So if you observe here, we have one binary search tree, right? Okay. So let us see. So if, here we can do operations on binary search tree. Okay. So for example, if I'm deleting any particular element here, okay. So if you observe, so in this binary search tree, okay. So for example, if I'm deleting this particular node called 70, okay. So if you observe, if I delete this node called 70 here, there was a node called 70. Yes. Okay. So here there was a node called 70. So if I delete this node called 70, okay, then how this should change? So if you observe, even in binary search tree, so even you do any operation, okay, so at the end your node should be in the again in the binary search format. Okay. So if you observe, even if you insert any element or delete any element, okay. So after inserting, you should again follow this property. What is the property? Left child will have a value lesser than the node, parent node, and right child will have a value greater than this parent node. Okay. So if you observe, yeah. So if you observe this 70, so if I delete this 70, what my node should become? My tree should become 50, 60, and 80. Okay. So it should not become like 50, 60, and 80. This should not. This is not possible. This is wrong. Yes, because 60 is not less than 50. So it should form it as 50, 60, 80. Okay. So normally in binary search tree, whenever we remove any particular node or insert any particular node, we should do rotation such that the resultant tree or the new modified tree should be in the form of binary search tree. Yes, you're understanding what I'm telling? So in binary search tree, so whenever I insert or delete any element, okay, so I should again rearrange the tree such that it again forms a binary search tree. Okay, so in BST, we need to do all those rotations. Okay, so but coming to this AVL tree, it is called as self-balancing. So if you observe, whenever I delete this 70, okay, so whenever I delete this 70, okay, so it automatically modifies this particular tree in a binary search format. Okay, so that is one thing, one important thing you need to know. And one more thing is like always, so whenever it is trying to do any rotations, okay, so it will again follow one more thing. Okay, so what is that? It will always make sure that, okay, so height of the left subtree. Okay, so for example, if I take here, what is the left subtree? So this is the left subtree. Okay, and this is the right subtree. Okay, so left subtree, right subtree. Okay, so even after arranging, okay, so after arranging, what happens after arranging? It will make sure that height of the left subtree, height of the left subtree and right subtree will be minimum. It cannot be always equal. Okay, so it can be either -1 or 0 or +1. So it will make sure that, so height of the left, difference between the height of left subtree and right subtree is minimum. Okay, so it can be 0 or yeah, 0 or -1 or 1. Yes. Yeah, a difference should not be more than 1. It is nothing but either -1 or 0 or 1. That -1 is nothing but if I do left sub, if only there can be a difference of 1. Okay, so either +1 or -1, or if both heights is same, it becomes 0. Okay, so those two properties uh, will contain this AVL tree. Okay, and yeah, so what about this red black tree? I hope everyone got an idea about what is an AVL tree. Yes, so still if you're having a doubt, please ask me. So what is an AVL tree? AVL tree is nothing but self balancing tree, and also it will make sure that, okay, so difference, okay, so difference between uh, left subtree, okay, and right subtree is, I'm just writing -1 or 0 or 1. That is nothing but minimum. Okay, so and then coming to right subtree. Okay, so coming to this right subtree, it is also kind of self-balancing. Okay, so it is also kind of self-balancing binary search tree, but then how it is different from AVL tree? Okay, so coming to this AVL tree, so AVL tree, sometimes what happens, so for a single insertion operation, it will do so many rotations such that it becomes binary search tree. Okay, so it need to satisfy this condition. What is that condition? Difference between left subtree and right subtree is either -1, 0 or +1. In order to make sure that this condition is achieved, it will make a lot of rotations. Okay, So sometimes single insertion or deletion operations, okay, so it will take a lot of time. Okay, so yeah, so all those things. So for example, so normal simple normal inserting operation itself is taking a lot of time. Okay, so it is then they came up with this red black tree. It is kind of self balancing tree, not as strict as AVL. Okay, so AVL is purely balanced. Okay, and then coming to this red black tree, it is also self balanced, but here they'll try to reduce these rotations. Okay, so to minimum, so that it will not affect this, so that it will not increase this time complexity. Okay, and also why it is called as red black tree. Okay, so why it is called as red black tree? Because whenever we try to mention, so either your nodes can be either black or red. Okay, so normally, so if you observe here, I've just used, unfortunately, I've used only this black and red. Okay, so and here we have some conditions like node, root node should be only black. Okay, so and then there are some conditions like red cannot have a red parent or red child. Okay, so kind of such conditions are there, so it will follow those conditions. That is why it is called as red black tree. It is called as red black tree because it nodes will be color coded. Okay, so either it will be either the nodes can be either red or black. Okay, so or yes, yeah, the main thing is I can tell it is nothing but it is kind of an not strictly balanced, almost or approximately balanced binary search tree. Okay, so why it is called as why it is made as approximately or almost balanced, because so if you try to achieve balancing, okay, so sometimes it might increase number of rotations, so which will increase time complexity. Okay, so when we are discussing, I'll in detail will tell you what are all these things. Okay, so for now, you need to understand what are these definitions. Yes, types of trees: binary tree, binary search tree, AVL tree, and red black tree. Okay, so yeah, so yes, guys, I hope you understood. So if you have any doubt in these definitions or in these types of trees, please ask. If not, we'll proceed further. Yes. Okay. So yeah. So I'm not getting any questions. So believing that everyone doubts got clarified. Okay. So we'll proceed to the program now, or building a binary search tree. Okay. So we'll see first binary search tree. Okay. So coming to this binary search tree, how this binary search tree is implemented? Yes. How this binary search tree is implemented? By using what? This trees or graphs is implemented. Okay, so exactly. So coming to this binary search tree, actually binary search tree is actually nothing but a doubly linked list. Okay, so our binary tree is nothing but a doubly linked list. It can have only two children. Yes. So for example, here data. So I am taking right. So instead of taking next and previous, I'm just taking left and right. Okay, so left will store the address of the left node, right will store the address of the right node. Yes. Okay, so yeah, for example, this, let us take this node's address is 100. Okay, so this node's address is 200, and this node's address is 300. Okay, so and let us assume here I have one more node. Okay, and here I have no nodes. Okay, so for example, if I want to fill these things, okay, so let me take 10. If I'm taking 10 here, I should have a lesser value, less than 10 7. Okay, less than 7 5. So greater than 10, I'm taking 20. Okay, and this should store address of the left node. So what is the address of the left node? 200. Yes, this will store address of the right node, which is nothing but 300. So these two are linked. Okay, and then coming to this one, So if I take address of this node as some 400, okay, so then leftmost node here shows the address of the 400. If there is no child, okay, then tell me what it stores. So for example, it does not have any right child. Okay, then what it stores? Yes, any answers? Exactly, Abhinay, it stores none. So we don't have null in Python, so it stores none. Okay, so actually it is not 5. It should be the value should be stored here. Okay, and same, it does not have any children, so it stores none. Okay, so same thing here also. None. Okay, so actually this doubly linked list is nothing but binary tree. Okay, so binary tree. So if you want to implement binary search tree, whenever we are inserting, we should follow these conditions. Okay, so whenever I get a value less than this 7, less than this 10, okay, so it should be on the left side. Whenever I get a value greater than this 10, I should insert it on the right side. Okay, so this is how we'll implement binary search tree using a linked list. Okay, so yeah, and one more thing. Okay, so I have checked the YouTube uh, what are those chart. Okay, so and yeah, so one of your friend, I hope, yes, suggested this thing also. If you observe, whenever I try to DQ, okay, so either in stack or in queue, so whenever I try to delete an element, first I should check whether there is an element or not. Okay, so this should be included. Okay, so I'm including it. Yeah, actually I forgot here. So whenever I try to delete an element, okay, so first I need to check whether there is an element or not. Okay, so for example, if length of self dot a is 0, okay, so print q is empty or no elements. Okay, no elements to dq, whatever. Okay, so else, so else if someone's speaker is on, yeah, this should be included in dq. Yes, please make these corrections if you are making notes. Okay, so if not, it's fine. So whenever you try to dq or pop, you need to check whether stack or queue is empty or what. If it is empty, we'll tell dequeuing is not possible. Okay, so if it is not empty, then what you can do, then you can dequeue an element. Okay, so that is about stacks and queues. Now we are discussing about trees. Yes. Okay. So let us see. Let us find. So here also. So whenever I want insert it, whenever I want to implement a tree or build a tree, what I need to do first? Okay. So I need to create nodes. Yes. Creating a node. So this node is nothing but actually a doubly linked list. Yes. So I'm creating a node. Okay. So node. Okay, and coming to here, every node should have 3 instance variables. Okay, so for that reason I'm writing it under constructor self. Okay, and same as like double linked list. Okay, I'll be passing an x value, so which should be stored in that particular node. Okay, so for example here self dot data. So if I'm taking my variable as data, self dot data is equal to x. Okay, so even if you put semicolon, not an issue. Okay, so and then instead of using previous and next, I'll be using left and right. Self dot left is equal to none. So initially, so whenever I'm creating a node, I don't know whether it has it, whether it is a parent node or a child node, whether it has nodes or not. So in default, I'm making it as a none. Okay, so this is about creating a node. Okay, so next. Uh, next what okay, yeah, So next, if you want to create one more class, you can create one more class and write. Okay. So or we can include it here only, not a problem. Yes. Okay. So directly, yeah. So if you want to create a one more class, okay. So we can create a one more class and then we can do. Okay. So that that thing we'll see tomorrow. Okay. So yes, guys, we'll wind up today's class. Okay. So I know sitting for 3 years is very difficult. Okay. So yes, if you have any doubts, uh, get it clarified. Okay. So and if you don't have any doubts, okay. So remaining tree building a tree and then traversal and graphs, we'll see tomorrow. Okay. And tomorrow timings I'll tell you. So whether I'm not sure whether we'll be having in the morning or in the afternoon. Okay. So I'll send you a message. Okay. But for now it's okay. Enough. Okay. So first I'm launching a feedback. Okay. So first everyone give feedback. Okay. So and if you don't have any doubts, please send your roll number in the chat box, and you can leave. Thank you. Thank you very much. If you don't have any doubts, please send your roll numbers in the chat box, and you can leave. Yeah, I have logged the meeting, so you cannot join again. So better send your roll numbers and then leave. Yeah, if you have any doubts, please ask. Please stay. Get it clarified. Bharat, speaker is on. Do you have any doubt?
Awesome.